derive expression for velocity of S.H.M, simple harmonic motion. We know displacement of S.H.M by A sin omega t. A is amplitude, omega t is phase. If this is plus sine, this is phase of displacement. This is equation of displacement. We have to find expression for velocity. Before doing this, differentiation with respect to theta, sine theta, it is cos theta, then d theta of theta, cos theta, this is 1. ddt sin omega t, sin omega t, cos omega t, then ddt of omega t, omega outside, cos omega t, dt by dt, that is 1. So remember, d dt sin theta, sin omega t, omega cos omega t, d dt cos omega t, cos minus sin, this is a rule for differentiation of sin cos, cos minus sin, sin का differentiation cos, फिर इसका differentiation ओमेगा टी का, ओमेगा outside dt by dt, तो sin omega t is omega cos omega t, and cos omega t differentiation with is minus omega sin omega t. Now back to question. Derive expression for velocity of S.H.M. This is displacement. We know displacement is this. How velocity? Velocity will be what? dy by dt. Differentiating it with respect to time, dy by dt, constant outside ddt sin omega t, this is v, a, this is omega cos omega t. This is velocity. This is not phase of velocity. Why? Plus is there, sine should be there for phase. What is this A omega? It is amplitude. Amplitude of velocity. B, A omega cos square omega t, equation is changed. under root. Now it is same equation. This is velocity. We have to calculate velocity of S.H.M. expression. This is velocity. Some further, it is 1 minus sine square omega t under the root a omega 1 minus sine square omega t. Look, equation first. It is sine omega t is y by a. It is y square by a square. A omega a square minus y square by a square. This a square cancels with this a. If you take it out, it will be a. Or velocity is omega a square minus y square. So this is expression for velocity of S.H.M. This is expression. Solve further, this will be expression. This a omega is amplitude of velocity maximum. This is amplitude of displacement. So this will be amplitude a omega, amplitude of velocity. Draw a plot, VT graph. We have drawn plot of displacement on similar pattern. T0, this is capital T. This is T by 2, T by 4, 3T by 4. Again, this is capital T, T by 4, capital T, T by 2, T by 4, 3T by 4. This is 0. Time 0. Cos 0 is 1. B is a omega. This point maximum, this will be 0, this will be maximum, but in opposite direction. This will be 0, this will be maximum. Again, time 0, cos 0 is 1, the velocity is a omega. So at 0 time, the maximum velocity. So this is amplitude of velocity. For next, if it is maximum, next is 0, next maximum but in opposite direction, next 0, next maximum direction opposite. This is plot of VT graph. This is VT graph. Special cases. Velocity at mean position. Imagine simple pendulum. Imagine यह मैक्सिमम वेलोसिटी होती है, यहाँ एक्सट्रीम पर 0, यहाँ 0, here it is maximum velocity, यहाँ 0 एक्सट्रीम पर रुक गया, then back 0. तो वेलोसिटी एट मीन पोजीशन, A case at mean y 0, putting in second v omega a square minus 0, v is a omega, maximum velocity. At extreme Y is capital A, putting in second B omega A square. Y is A, so A square 0, B is 0. Minimum velocity. So maximum velocity is A omega, A amplitude, mean bar. This is mean position, this is extreme, it is 0. A omega is amplitude. Derive expression for acceleration of S.H.M. We know displacement of S.H.M. that is y a sin omega t. This is amplitude of displacement, this is phase. Differentiating it with respect to time. dy by dt a ddt constant outside differentiation sin omega t. This is b, a is a differentiation omega cos omega t. This is velocity. This is not phase, there should be sign. Differentiating it again with respect to time. dv by dt a omega constant outside dt cos omega t. It is a omega minus cos omega t sin omega t. Omega t is omega or a is minus a omega square sin omega t. This is acceleration of S.H.M, expression for acceleration. This is not phase of acceleration. Here should be plus, then there will be what? Phase. Or a sin omega t is y. A sin omega t is y. Fourth, why? Because A sin omega t is y. Equation was there. So this is expression for acceleration of S.H.M. Plot. We can't draw plot from here. We can draw plot from here. Time 0. 0. This is time capital T, this is T by 2, this is T by 4, this is 3T by 4. Capital T, T by 2, T by 4, 3T by 4. Time 0. Sin 0 is 0, A is 0. This is maximum but in negative direction. First 0, second maximum, third 0, fourth again maximum 0. So this is plot. And this will be amplitude of acceleration. This is positive amplitude, this is negative amplitude. A omega amplitude of velocity, this is amplitude of displacement. So A omega square maximum acceleration or retardation. So what this equation says, that is retardation is there, that is acceleration is directed towards mean position. So the question is, show acceleration is directed towards mean position means the same question derive expression for acceleration. Third property is proved. This was third property of S.H.M, acceleration directed towards mean position. So, retarding force restoring force directly proportional to displacement. You know, displacement y A sin omega t, एक्सेलरेशन पर पहुंच जाइए, डिफरेंशिएटिंग इट विद रेस्पेक्ट टू टाइम वी विल गेट वेलोसिटी dy by dt, v का कांस्टेंट d dt sin omega t, this was dy by dt, so v a differentiation omega cos omega t, differentiating it again with respect to time dv by dt, a omega outside d dt cos omega t, this is a omega minus omega sin omega t, a omega square sin omega t, third a omega square y, fourth. We have already done this. Now question is force, restoring force, retarding force. Multiply both sides by m, m omega square y, this is force, m omega square y, ky, k is m omega square, m constant, omega constant, this k is constant, called force constant, called spring constant. If spring is oscillating, then it is spring constant, or F, that is retarding force is directly minus retarding, directly proportional to displacement. Force constant spring constant, if oscillating spring is there, then it is spring constant. We know F minus ky, this k is force constant, k minus F by y. If y is 1, k is minus F. Restoring force per unit displacement. This is restoring force, this is 1. Restoring force, retarding force per unit displacement called force constant, units, SI units, F by Y, Newton per meter, CGS, dyne per centimeter, dimensions, F, L, M, L0 T minus 2. So this is kilogram. This is per meter square. ग्राम पर सेंटीमीटर स्क्वायर. यहाँ से अनदर यूनिट्स, angular velocity of S.H.M. We know K m omega square. This K was placed instead of m omega square, so K is this. K force constant, m mass oscillating, omega angular speed. So omega square K by m, omega K by m root, angular velocity of S.H.M, frequency of S.H.M, expression. We know K m omega square K by m, omega K by m root, omega 2 pi nu. Again look, omega theta by t. If t is capital T, then the angle will be 2 pi, and 1 by t is nu, time period reciprocal of frequency. So nu is 2 pi K by m. time period of S.H.M. We know K m omega square is K, so omega square is this omega. What is this omega? 2 pi by t, just discussed. T 2 pi this is time period of S.H.M. Find phase relation between displacement and velocity of S.H.M. Phase relation. We know displacement of S.H.M. that is y a sin omega t. This omega t plus sine, this is omega t is phase of displacement. Differentiating it with respect to time, dy by dt, a constant outside, d dt sin omega t, or b a omega cos omega t. Velocity. This is not phase. Sin 90 plus theta cos theta. Plus should be there, sine should be there, then we will get phase. So this equation becomes a omega cos theta sin 90 plus theta sin theta plus 90. So this is phase of velocity. This is plus, this is sine, this is phase. Compare first and third. This is first. This is phase of displacement. This one is phase of velocity. Velocity is ahead in phase pi by 2 from displacement. So this is phase relation. Or displacement lags behind velocity in phase pi by 2. Suppose we want to draw plots. Plot of displacement. This is the plot. 0, then maximum, दिस इज वाई ए साइन ओमेगा टी। ये यहां से करते हैं ड्रा। टाइम 0 1 मैक्सिमम, then 0, then maximum, 0 maximum, this is V A omega sin omega t plus pi by 2। ये 2 पाई फेज है, 2, दिस इज पाई बाई 2। तो वेलोसिटी पहले ही एक्सट्रीम पर है, कितना पहले, पाई बाई 2। तो अहेड होगी, वेलोसिटी इज अहेड। अगेन 2 पाई इज दिस फेज, दिस इज पाई, टोटल एंगल 2 पाई, दिस इज पाई बाई 2। ये वेलोसिटी पहले ही एक्सट्रीम पर है, इसका मतलब पाई बाई 2 आगे है।